Hi everybody. In the last few videos we have been discussing about the reactions of organonickel reagents. In this video I shall discuss with you one particular reaction in which organonickel reagent is used, and that is shop reaction or shop process, which is an industrial method or industrial process. Now shop process is nothing but shell higher olefin process. Okay. Now this name shell comes from the inventor or the person who found this process, that is Royal Dutch Shell. Now this particular process involves the production of higher order olefins. Okay, and these olefins are used for the synthesis of plasticizers and detergents. Okay, now these olefins are of C12 to C18 chain length, that is 12 to 18 carbon atom chain length, and this happens via ethylene oligomerization and metathesis. Now there are three steps involved in shop. One is the oligomerization of ethylene. The first step is oligomerization of ethylene. The second step being the isomerization of C14 to C10 carbon length polymers, and also polymers which are greater than C20 chain length. And then finally we have the metathesis. Okay, so these are the three steps involved in shop. Now the olefins, as I said earlier, the olefins which are formed are converted to fatty aldehydes and then to fatty acids, which are the precursors for the production of plasticizers and detergents. Okay, we do not require very long chain or high molecular weight olefins. We need to bring down what we can say, we need to limit the chain length to C12 to C18. That's why we go for this process. Again, that's the importance of this process too. Now let us see in detail each step. First one is the oligomerization of ethylene. Now in oligomerization of ethylene, you know what is oligomerization. It is of course similar to polymerization, but less number of molecules are involved. So here you can see you have got n number of ethylene molecules in the presence of nickel catalyst undergoes polymerization. And the chain length can be from 2 to 38. The n value here can be 2 to 38. That is, here you will be having 1 ethylene moiety or 37 ethylene moiety. Alright, and you will be having a terminal alkene over here. Okay. Now this nickel catalyst is produced in situ during the reaction from NiCl2, PH2, this is nickel chloride, phosphine group, and a reducing agent, sodium borohydride. So these three result in the production of the nickel catalyst. And also other reaction conditions required are 90 degrees centigrade to 100 degrees centigrade temperature and 100 to 110 bar, and the presence of a polar solvent. Usually the polar solvent used is 1,4-butane diol. One important aspect of this step is that we get a mixture of linear, even-numbered alpha olefins. Okay, by the term alpha olefin we mean that there will be a double bond in the alpha position, first position of the terminal double bond. And we get carbon chains, polymer chains of C4 to C40 chain length. And it is formed, the oligomers are formed based on the Florey-Schulze distribution. Now that is the chain length. You can see here, this will be the distribution of chain length. This is called the Florey-Schulze distribution. See here, you can see this distribution is a probability distribution of polymer chains during polymerization, and here the distribution, the Florey-Schulze distribution implies that shorter polymers are favored over longer polymer length. So here you can see here chain length of 6 is more, 4, 6, 8, 10, up to here we can see more, while chain length from 12 to 20 it's decreasing number of polymers. Okay, so that is Florey-Schulze distribution. I think you would have knowing more, you will be knowing more about this when you are studying about the polymers. Okay, so oligomerization of ethylene, we get polymer chains of C4 to C40 chain length, and the chain length distribution is based on Florishow's distribution. Now the second step, that is double bond isomerization. Now this happens in the presence of solid potassium metal catalyst. Okay, so here the catalyst is potassium metal. One thing I want to tell you, the nickel catalyst is used only in the first step, only in the oligomerization step. Okay, now we have discussed in detail regarding the alkene-alkyne oligomerization in my earlier video. You can just watch that for your reference. Now here, to complete the shop process, the double bond isomerization happens in the presence of potassium metal. Okay, and this step is to increase the distribution of the C10 to C14 fraction. You have seen that it is the C4 to C10 that is more, or in fact C8 that is more in number. We need to increase this fraction, and that's why we carry out this double bond isomerization process. Alright, so what happens is, you have the term alpha olefin over here. The double bond is shifted to the inner parts of the polymer chain. Okay, so that happens in the presence of potassium catalyst. Now the last step, that is the metathesis step. You can see here the metathesis happens, that is you get variety besides C11 to C14 chain alkenes are formed, and then these alkenes of different chain length are separated by distillation and converted to detergents, detergent alcohols via hydroformylation or to detergent alkylates. Okay, so you get the uniform distribution of this particular chain length, C11 to C14 chain length. So here you have a higher chain length. Here you have a 9 plus 7, that is we can say 1, 10, 12, 13, 20, 21 carbon atoms are here. This is broken down. Here you have 1, 2, 3, 4, you have only 4 carbon atoms. So this 21 and 4 will come together, metathesis happens, and you get 1, 2, 3, 10, 11, 1, 2, 3, 12, 13. See, 11 and 12 carbon chain length polymers are formed. And the polymer, the double bond is not terminal now. We are not getting alpha polymers here. Okay, you're getting internal alkenes. That's important. Okay, so the during the isomerization process, we get the internal alkenes, and also during the metathesis process, also we are getting the internal alkene. Only in the first step we are getting the alpha alkenes. Okay, so and only in the first step we are using the nickel catalyst. Okay, so let us see the industrial production. What is the flow chart, or what is the scheme of production of carrying out this shop process. Now, one more thing we must remember is, I forgot to tell you, this particular metathesis step happens in the presence of alumina catalyst, alumina molybdate catalyst, alumina supported molybdate catalyst. Okay, and you get both even number and odd number. As I said earlier, you have both even number and odd number polymer chains, number of carbon polymer chains. Okay, now this is the scheme of the whole shop process. See here, you introduce ethene to this chamber, and then oligomerization happens. Now, if ever any more ethene is present, it is taken back and then again mixed with the catalyst. Okay, and then during oligomerization, we get different olefins of different chain length. That's why we have got 3 different shades over here. And then it is in this chamber that the separation happens again, and if ever ethene is there, it is again taken back here and the mixing happens. Again it is taken for oligomerization. And out of this chamber, out of the separation chamber, we take C4 to C10 polymer chains and also C12 to C18 polymer chains. So we are separating these two. Okay, and then from the separation chambers, the polymers with chain length greater than C20 is taken to the isomerization chamber, and also this C4 to C10 polymers are also taken to the isomerization chamber. Now remember, we need this particular chain length, so they are left, they are taken away. Now in the isomerization chamber, isomerization happens, and here again mixing happens, and we take it for metathesis. Okay, and after metathesis we get the C10 to C14 chain length polymers. Now during the metathesis again separation happens, polymer chains less than C10 is again brought down to the mixing chamber. Okay, and during metathesis, if ever carbon 14, a polymer chain of higher chain length, that is above 14, carbon 14 is formed, it is again brought back to the isomerization chamber, and from the isomerization chamber back to mixing. Okay, metathesis, mixing here means we are going to mix it with the alumina supported molybdenate catalyst. Then again to the metathesis chamber. So this is done until we get a polymer chain of C10 to C14. Here we get a polymer chain of C12 to C18. So this particular chain, the polymers of this particular chain length is taken for the preparation of plasticizers and detergents. So hope this is clear to you. I'll just tell you once more. You take the ethene, take it to the mixing chamber, mix it with the nickel catalyst, carry out oligomerization. Here, one step screening is done from the oligomerization chamber. If ethene is present, it is taken back and again taken for mixing. And then from the oligomerization chamber, the whole the products are taken to separation chamber, wherein polymers of chain length C4 to C10 and C12 to C18 are separated. C12 to C18 are taken for the production of plasticizers. C4 to C10 polymers are taken for into the isomerization chamber. Also polymers with greater than 20 carbon atoms. Okay, here isomerization happens in the presence of potassium catalyst, and then we take this for mixing to mix it with the alumina supported molybdenate catalyst, and from here we go for metathesis chamber, where from there we get the C10 to C14 polymer chains. Now in the metathesis chamber, if ever there are polymers with less than C10 chain length, we bring it back to the mixing chamber. Okay, and also if there are polymers with greater than C14 chain length, take it to the isomerization chamber, isomerize it, take it to the mixing chamber. Okay, so this is the process happening. This is the flow chart of Sharp process or Sharp synthesis. Alright, so hope it is clear to you. So this comes, this brings almost to an end of our discussion on nickel reactions related to nickel organonickel reagents. Remember, in the Sharp process, it is only the first step that we are using the organonickel reagents. Alright, so thank you for watching my video. If you have any clarifications, please feel free to ask. Thank you.